You are now starting to see problems in your homework on exponential equations. So we are going to take notes on writing an equation for an exponential function. So exponential functions, so this is y equals ab to the x. So we're going to learn how to write equations in this form. So I'm going to show you 3 different ways to do this. So this would be a typical example that you would see. So the example would state, find the exponential equation through 2 points. Being 135 and 1,715. So this is a very traditional problem. I can give you any 2 points. Again, we have an exponential. This looks like a growth. It's going to be like this. So maybe one of your points is here and one of your points is here. So write the exponential equation through those 2 points. So I'm going to show you, again, 3 ways to do this. I'm going to show you how to do it with a table. I'm going to show you with elimination. And I'm going to show you with substitution. So with a table, this one you can kind of logically think through. And sometimes it's easier than others. So if I have an XY table, I set up my coordinate points, 135 and 1,715. So what I know is that exponential functions, as x increases, y multiplies. So exponential function is like an add multiply scenario. So whatever it's multiplying by, that's what I have to figure out to get from 35 to this term and then this term to my 1715. So what ends up happening is because I'm missing a term in between here, so this is like having 2. So whatever this value is here, I have to take 35 and multiply it by some value. That's the b value. B is your multiplier. It's being multiplied over and over and over again. So 35 times some value gives you this one, and then this value times that same b value gives you 1715. So what you in essence could do is you could set up an equation. 35 times b equals 1,715. Well, that's equivalent to 35 times b squared equals 1,715. Pretty easy equation to solve for. Divide both sides by 35, so you get b squared equals 49. Square root both sides, and we get b equals 7. Technically, b is positive and negative 7, but for an exponential function, it can only be positive 7. So I found what my b value is. And once I know my b value, I can then go backwards and find my 0 value, because my 0 value is always a. Because if I put 0 in for x, y equals ab to the 0. What's b to the 0? That's just 1. So therefore, the value of y, my y-intercept, is my a value. So I could then again plug my value in and go backwards. So going forward, I'm multiplying by 7. So going backwards, I'm dividing by 7. So I get my a value. So y equals 5 times 7 to the x. Don't multiply 5 and 7. That's it. A and b are both parameters in there. You cannot combine them together. So that's how you can use your table. Or if you didn't think about it as going back this way, you could plug in a point, plug in 35 for y, plug in 1 for x, and then put your b value in and solve for a. That's another way to do it. Okay, option 2 is with elimination. Because sometimes it's not always easy to see how many times you actually have to multiply this b value to keep going to get there. So another option is you can set up a system of equations. So the system of equations is y equals ab to the x. Remember, y equals ab to the x. So I'm going to set up with both of these points. What you need to do is pick the bigger x value. So substitute 1715 in for y. That equals ab cubed. And then substitute 35 in for y, and then that's ab to the first. Now you can hopefully see that a and b are attached by multiplication. So what I'm trying to do is I'm trying to eliminate a variable. So what I'm going to do is, because they're attached by multiplication, what does multiplication is division. So I'm going to divide both sides by the same thing, or its equivalent. So what I'm going to do is I'm going to divide ab cubed by ab to the first, which means 1715 I'm going to have to also divide by ab to the first, or its equivalent. See how it says ab to the first equals 35? Therefore, I'm going to divide 1,715 by 35. So I use my calculator for that, and then I get 49 And then a divided by a is 1, and b cubed divided by b to the first. We just did exponent properties, so when I'm dividing and base are the same, I subtract exponents, so that's b squared. Square root both sides, you get b is 7. Again, it would be positive or negative, except for this is an exponential function, and your base can't be negative. Now, how do I find the other one? Plug it in. So plug 7 into either of these two equations. So 35 equals a, b is 7 to the first power. Divide both sides by 7, a is 5. So your equation is y equals 5 times 7 to the x. This is my preferred method, is elimination. The other option that you can do is substitution. And this one, in my opinion, is a little harder to do because you have to really keep track of things. So the last one is substitution. So with substitution, we have both of those equations. So 1715 equals ab cubed, and then the other one was 35 equals ab to the first. So with substitution, I need to solve one of these two equations and get a by itself or b by itself. I recommend getting a by itself just because both of these a's are in there with no exponents. So what I can do is I can take this bottom one and I can get, again, a by itself, which means I have to divide both sides by b. In this case, it's b to the first. Now, since I have this in terms of a equals, I can take this and plug it in place of a. So 1715 equals 35 over b to the first times b cubed. Multiplying, so that's like over 1. So a b cubed over a b to the first is a b squared. So 1715 equals 35b squared. Divide both sides by 35, which gives you 49, equals b squared. Square root, b is 7. Now, because I solved and got a by itself, now I can take that 7 and put it in for b. So I have 35 over 7 to the first, which is a, therefore a is 5, and I get the exact same equation, y equals 5 times 7 to the x power. Just showing two different screens, that way you can see the whole thing. So it does not matter a bit which of these methods you prefer. You can set up your table and logically think it through. I do need to see some kind of work here. You can set up elimination. Note, when you're doing elimination, you want your higher exponent on the top. So whichever of these 2 points, whichever x value is bigger, that one you want to go on the top. Otherwise, you get a negative exponent. Or you can do substitution, where you solve for one of your variables and substitute them in.